Welcome again, everybody, and thank you for joining our global webinar day. Today's topic is Stop Flying Blind Through Cloud Services, information on how to ensure cloud services quality with Infosim StableNet. My name is Dietmar Kneidl, Director of Sales Europe with Infosim, and I will be your moderator for today's event. Joining us from his office in Munich, Germany is my colleague Peter Moessbauer, Strategic Alliances Manager at Infosim. Good morning, Peter.
Good morning, Dietmar.
Peter will present and guide us through the webinar today. But before I hand over to Peter, I just wanted our audience to know that all of you are automatically muted just to keep down the background noise. So in order for us to answer your questions, please type them in the questions window or in the chat window at the bottom of the GoToMeeting application. We will be answering all questions either directly during the webinar in the chat or right after Peter's presentation in our Q&A session. Also, please take note that this event is being recorded and all registrants will be notified via an email tomorrow on how to access the recording. Well, that's it from my end, so now I'd like to go ahead and turn things over to our presenter, Peter Moessbauer. Peter, you ready?
Yes, of course. Dietmar, thank you very much, and thanks
Welcome.
for the good intro. Yeah, good evening to Asia, good morning to Europe. So I have today the pleasure to show you some insights on managing cloud services, and so let's just start. Yeah, cloud services. Well, everybody knows them. There are many around, like Amazon Web Service, Google Drive, Yahoo Sherpa, Dropbox, Yahoo, Microsoft Azure, Offline 360, OneDrive, Netflix, Salesforce, Apple iCloud. So in Europe, T-Systems with the vCloud, and so plenty of services there. Everybody is using it. Even longer than many were thinking about. WebDE many years ago was also a cloud service. But of course there are certain challenges, and you know, on the cloud services or services, the next service is just a mouse click away, and so it's absolutely key to ensure the service quality. And one challenge, of course, is the internal infrastructure, globally spread, and then the external providers' infrastructures, which the cloud service provider usually doesn't have under direct control. And last not least, the users of the cloud services, like end customers, like corporations, everybody is relying on, and there are multiple services, of course, on the web, and some of them are, you can say, best effort services, or others are mission critical if you run a corporate business, or if you are using VoIP or IPTV, they are real-time critical. And you know, to watch a video on an internet service which has a lot of pixels or stops, or based on a bad infrastructure, wherever it comes from, of course, is not a pleasure. So it's absolutely key to, when services like that are provided, to do cross-silo, cross-country monitoring, because all is composed by IT services, by network services, and the last not least, access networks and the provider to the users. And for that, absolutely holistic service views are required. Otherwise, a provider can't identify where the bottlenecks are. In the follows of this, it is key to monitor from the user's perspective. So, you know, that is where the service ends, and that is not so easy part, because to monitor from the user side requires to have equipment there, and just to monitor it in a couple of few spots is usually not good enough because you might missing large areas on the globe where a provider even can't tell if the services are working there, or even if they can tell and the performance is not sufficient, where the issues are. And to get into that, to monitor from the user side, there are, of course, users are using a zoo of applications. Every cloud service offering is providing by nature multiple different applications. Multimedia traffic end-to-end is encoded in, is running in real time, and then you need reliable reference sites in terms of not be depending on user equipment turned on and off. You know, if a user can't access a service, he might be not just not using it, or might be cut off for various reasons. And also there are infrastructure elements. You know, how far does your service reach with good performance, and where do hotspots and problems start? So next hop performance monitoring is also a key element. Let's go in and look how this can be addressed. So the monitoring scope, of course, is cross-silo, IT, networks, distribution, applications, and there are certain areas to view that. First, you need a holistic service view. You also need to see that in real time. It would be good to know about trends. You know, a service which is well received is attracting a lot of users, a lot of traffic, and this could lead to a trend where you run out of resources in a certain area. It would be good to know, to invest before the problem starts. And also proper reporting is needed to document and plan on the service, to also get the feedback as a cloud service provider. Then you need the infrastructure monitoring. This is the internal stuff. You need to know the external capabilities, and of course end-to-end, which decomposites in the following areas. There are some cloud service applications used by providers where there is a monitoring integrated in the application, but of course it tells if the user can operate, can work, and the performance there. Also it does failover, things like that, but it's missing out the infrastructure. So it's just a way to address it, but it's not sufficient. Then cross-application, of course, is the service generally available. And if you need to monitor complex applications, especially in business environments where you might want to, you might offer SAP applications on the cloud, or could be some transactions, credit card transactions, things like that. You might consider synthetic transaction monitors for replaying and testing and running complex applications. And then, last not least, small site monitoring. As mentioned before, if you monitor your cloud services just in some areas or so, you know, per country, one hop, or one spot, or a couple of spots, that is usually not enough, because there are multiple providers used by the users. They are very distributed, and normally, technically, you could, of course, put things like shadow routers in there, where you have a local installation where you could monitor from there end-to-end test services, but they are usually very costly. And there it is much more efficient to deploy a large number of small, low-cost agents to do such type of a monitoring. That's like with a Raspberry Pi platform type. I will show more on that. Yeah, as said, absolutely key to do cross-silo from backbone, IT, infrastructure, applications up to integrating business process monitoring. You might, as a service, cloud service provider, have your own business process monitoring, which you need to integrate into the holistic view. And that's actually what we make possible here in terms of integrating just external BPM monitoring processes via just defining the input and the output, and it's very easy actually to get it into this StableNet solution, of course. And on the networks, it's a zoo of grown environments over the decades, from historic networks in terms of backbones, SDH networks, could be SONET, and migrating up to more and more new networks. There can be MPLS in between, layer 2, layer 3 VPNs. It depends also on the service and the distribution. Then you can expect routers, switches, load balancers, firewalls, media gateways, a whole bunch of things. In the server area, of course, the servers, virtual servers, databases, applications. And then on the application level itself, most critical, multimedia, because this is real-time traffic. It has to have low packet loss rates. It has to have low jitter. Audio and video need to be in sync and things like that. And of course, as said, business process monitoring. Yeah. One key element, of course, is, in such large environments and structures and distributed structures, every cloud service provider has usually 2, 3, or more data centers, infrastructure in between, and the infrastructure could be, of course, manually imported or designed. But it's much more smart, as it might change, and it might be dynamic assignments and reconnections. Also think of software-defined networking. It can be dynamically assigned. It is absolutely, it eases the life to discover these infrastructures. Of course, you define what you want to discover, but if the system then does this discovery and updates it basically every day or on demand, then it's a big part of the job is already done in terms of knowing the infrastructure in between. This can be internal, this can be external. It also depends what view you will have on the external service providers. That can be limited, but sometimes you can monitor from the outside, also using our Raspberry Pi platform agent types to monitor outside of a given black box infrastructure, which you can look into. As said, to monitor, of course, the IT infrastructure is mainly in terms now of monitoring virtual systems, databases, also to track capacity and trends. As said, good services, good cloud services attract a lot of users. This could be a killer for your infrastructure if you don't invest in the right spots to cope with the growth and the increased utilization of the infrastructure. So trends will help on that. I won't go in details on IT because this is a very well-known part, and StableNet covers that well, so most of our users know it. Then, of course, the networks. Networks are not just one layer. They are grouped or stacked in layers. And depending on what visibility you have on the infrastructure, you could really go down to the carrier networks. But this depends on what you can see. So usually, as a cloud service provider, you can see your internal network. The external networks depend on what visibility your provider does allow you to have, or what did you negotiate on that. If you have no visibility, the black box approach, monitoring outside from, let's say, a type shadow router to a shadow router, is a possible option to take care about that. Yeah, I promised to show something about the Raspberry Pi platform, how to do this low-cost end-to-end monitoring, and we have developed a solution which is now very well received by many telcos, large enterprises. So we enabled to put the StableNet agent software on small Raspberry Pi type platforms. So this can be a Raspberry Pi, it can be also a Banana Pi, which is much more powerful. We actually put it in a black box so that the users will not be able to locally connect and fiddle around with it just for security reasons. You as a service provider can still access it from remote, that's no problem, so just the local users shouldn't be enabled to access it. You can actually put such a device in a envelope, send it to, for instance, a bank office or a user or reference user, and they just plug it on, and then this agent will be connect to the central pre-configured StableNet server, and from there you can control these devices. They are in a very low-cost range to allow deploying of thousands or 10,000s of these devices, and to really have good visibility on the distribution and the distributed availability of your cloud services. Of course, these small Raspberry Pi agents have their limitations, so there's no good for doing NetFlow or things like that, heavy load, but to discover 50 devices or run several end-to-end VoIP or video simulation calls in parallel or tests is always a possible option. But this brings visibility into the distributed availability of cloud services. So basically, you stop flying blind on that. I had seen that quite often with large managed service providers in telcos, that they had a good visibility on their internal network, but they didn't know if the customer actually had received their services because they didn't have the network to monitor customers was not dense enough to have a good visibility. So what can you do with that? Yeah, of course you can do the passive monitoring as usual, so mainly SNMP, CSV, read-ins, things like that, but the more important part actually is the active reference monitoring. So such a platform can play the role of a user to access some or test some end-to-end video streams, so from one end to the other, so you know that your infrastructure will work in between. It's actually not a video testing device itself, that it looks at TV and monitors TV programs. This is something different, but you can, the most critical part, of course, is the infrastructure, so you can send end-to-end encoded video streams or multimedia streams, for instance, H261 or the H264, or you can also simulate VoIP and IP telephony calls. You can issue SIP calls and monitor the key parameters on that, including the MOS. Of course, monitor IP traffic, simulate IP traffic, and also access URLs, like a user would access your service via a URL, and you could test if it works, if the performance is there. You can initiate downloads, test DNS access if your addresses get resolved, things like that, from the customer's perspective, of course. Yeah, the configuration, of course, if you deploy several thousands or 10,000s of these small agents, a manual configuration would be a very tedious task. So these agents can be, as other agents or normal or regular StableNet agents, can be centrally configured via the central StableNet server installation, and there the configuration can be set, can be distributed. You can also offload or download media measurement scripts. I did show on the low end of this picture, the screen, I show some of the preset codecs. Codecs are just can be seen as a preset encoded ensamples, codec ensamples. So you can also add other codec or simulate other codecs by adding the right codec samples. They are sent from agent to agent, and the KPIs, key KPIs, performance indicators are monitored on that to see if there are issues with jitter, with packet drops, if the MOS quality or what MOS quality is finally resulting in this tested end-to-end monitoring. And it is on high scalability, so we have even customers out there that are running around currently at 70,000 distributed agents. That is, but there's no hard limit on that because within StableNet, most work is performed by the agents, and the more agents you have, the more powerful the system gets. So it's a very good way to really scale to the very large if required. Yeah, reference monitoring, the way how it works is one StableNet agent acts as, for instance, multimedia master. There are RTP streams sent to a remote StableNet agent. A remote StableNet agent can, of course, measure that, and he can also return RTP streams or encoded streams to the other StableNet, and the StableNet agents can be interworked, of course, by that. By doing that, you can also indicate on trends like to see if, for instance, performance is degrading over time of day or time of the week or months or the year. And of course, all the StableNet reporting and monitoring capabilities are still there. So, you know, even that it's small agents, but the analysis and the processing of the reports can be visualized from the central StableNet system as usual. So it's actually the same system, so nobody has to really learn a new system to make utilization of that. Passive monitoring as before, and you can use all on the Java GUI or the rich GUI or the web GUI. You can use all the screens and features and reports as before. There is no change actually to that, which makes it which enables you all the benefits of the central StableNet platform, but using it on a very, very large scale of distributed monitoring agents. To give you some examples on typical solutions to use that. So in distributed networking environments, I'm taking an MPLS as an example, but this would work, of course, in any other environment that you can put at any spot of your network or distribution network or global services network. You can put one of these small agents, and you can monitor in between the different hops. So you can monitor hop to hop, or you can monitor end to end as required in a very, very efficient and cost-efficient way, and you gain always the visibility which part of the network in case is not performing as required, or if there are trends that areas tend to get overloaded. In video IPTV distribution environments, I did show a typical example where you have like a super head end, you have the regional video hub offices, the regional head ends which collect the different video streams. Then you have of course a core network in between. It can also be an international network. Of course, this is just an example of a typical structure. Then you have video services offices where you, for instance, insert regional TV streams, programs or so, which have no global or national scope. And then you have the access and aggregation networks below, where you have can be cable, it can be GPON, it can be DSLAM, whatever. And the Raspberry Pi based platform-based agents are usually residing at the customer site or customer spot. Normally, telcos make use of their own employees, so they get an agent to monitor that. Of course, the agent doesn't monitor the user behavior, what the user looks on TV. These agents monitor, do reference testing, so they send and receive encoded video streams and monitor the quality in between, and so they can do it hop to hop or end to end. They can also test, combine things like is the URL with a certain service available, and then is the path for the video stream available. Things like that can be very efficiently and also cost efficiently monitored, tested, and of course deployed across the country or globally, especially on new upcoming global services. I'm thinking of Netflix, things like that. They have a global scope and need to know, of course, if their services are available in the different regions. Then on VoIP systems, of course, it's quite similar. StableNet agents can issue SIP calls. They can monitor the calls in terms of they can issue calls by themselves, simulate calls, and monitor then, of course, encoded traffic. This works, of course, in combination with classical monitoring on the backbone infrastructure like the routers. You can simulate internal, external traffic, things like that, and also, of course, multimedia as required. Actually, by this structure of distributed agents, this allows a lot of flexibility to do such monitoring tasks. And of course, it also runs across firewalls and VPNs. You know, spreading out agents across the network, especially in managed service provider environments, of course, there comes one big question up. This is the security. And StableNet central installations to agents allow an encrypted communication, for instance, IP port 5100, and they can work easily across firewall. On the firewall, you just have to open one dedicated and configurable IP port, and not a bunch of ports or dynamic assigned ports like you would normally do on a management installation. So, and this allows a very secure distributed operation. Of course, also the information to customers can be encrypted. StableNet provides a role-based system to also allow user and different provider access. As you as a provider require that, and as you as a provider set up roles for the different access and for your internal and external users. A key area also on cloud services is if you are running complex services, then end-to-end replay of full user transactions might be required. We do that for simple applications like URL, HTTP, DNS, also some dedicated services like, for instance, Salesforce Access, we do it, or Oracle Access, we do it directly. If it's very complex end-to-end, like a SAP transaction or a credit card transaction, we interwork with third-party end-to-end system transaction monitors, which replay full applications, and we can track that also, the results and performance via the StableNet agents. Modeling cloud services, absolutely key. How do you get the visibility on that, and how does that look like? Of course, you have the internal infrastructure, you have the external infrastructure, and multimedia services and applications. So what StableNet, of course, allows us to do, as this is a cross-silo management application, you can combine that into dashboards, you know, because nobody wants to day by day look into details. It's better to have a dashboard where you see all your services on. You might want to know the global distribution on that, so that can be set up. For troubleshooting, of course, then you go into charts, do detailed analysis, drill down on the different areas and do real-time analysis on that. And of course, reporting, it's key to document the service quality and the trends over time for management, and this can be also automated by report schedulers. How to model that? StableNet allows to model that by a very efficient system, because it's running on a consistent data model. you can combine the different areas which your service decomposites into and have the different groups and combine that into an overall service. For instance, I'm showing here the Salesforce.com, which is the cloud service, but of course it consists of all sorts of web servers, infrastructure, middleware servers, and the access to router network, DNS, and things like that. And by that you can map that to your dashboards, to the service availability, or to the infrastructure. A wrap up on that. Base that we use here is StableNet Telco. It allows to do the service assurance. So the use of a Raspberry Pi type platform or Banana Pi is basically an extension to the StableNet, utilizing all the features StableNet has. You can do the orchestration, also automation on things by also doing mass configurations and changes on network devices. You can also monitor policies, vulnerability, things like that, which always come up in such environments. And technology support. Technology here is vendor agnostic. It's cross-silo. It works on clouds. We support software-defined networking. We can even adapt to big data processing. We can do large volume CDR, syslog processing. We could also integrate with big data sources. And of course, it's always good to work on standards, because it keeps the infrastructure, next generation networks, the OSS compatible to your existing environments, and that's why support ETOM, ITIL to fit into your existing environments. And last not least, money. We all earn money on that such solutions and on services. So it's always a matter of fact what is cost efficient to invest in small sites and management. And Raspberry Pi type platforms or Banana Black Box, they are in total in the range of around 150 euro per black box. This is the card. This is the flash card. This is pre-installed StableNet agent software and agent license with that. So it makes it very easy to extend the StableNet solution by a large number of remote monitoring devices. Yeah, any questions about that? Dietmar, did you monitor?
Yes, I monitored our chat and questions window during your presentation. Thank you, Peter, so far. We've gotten a number of questions, some of them evolving around the Raspberry Pi type platform agents, so maybe we should elaborate on that a bit more. We've started about a year ago to enable our StableNet agent to run on cost-efficient hardware or hardware with not so many resources on board, and the final result was development of a Raspberry Pi or Banana Pi type platform device that will be available by end of year. So we've put our resources together and combined them with a hardware manufacturer now. So these devices are built for Infosim directly. We didn't want to use off-the-shelf Raspberry Pi or Banana Pi agents because they contain a lot of functionality that we actually don't need. So as Peter already mentioned, these Raspberry Pi platform agents or Banana Pi type platform agents are available now, and he gave a number of examples on how they can be used or how they are being used already. Apart from that, we've received a number of questions regarding the presentation slides, whether they will be available in a PDF format, And the answer, of course, is yes, they are available. Just send us a quick email. I'll just type my email address in the chat again. So just if you want to have a copy of those, just send us a quick email. And well, I think we have one more slide, Peter, or a couple more slides. Oh, yes, our most favorite slide.
Of course, Dietmar. we like that very much. We had received this EMA report in around August, beginning of September this year, and you can see Infosim with StableNet made it up to the top right corner. I always make the joke, HP might be a bit higher up because they are bigger, but we as Infosim are still working on that. So, but this is a very good feedback from the market that this consistent and advanced and very efficient and automated solution, you know, automation is a key element on that, brought us to the top right corner, and of course we're working on to stay there, you know. So you know, we can't go, shouldn't go anywhere else, you know.
Yeah, I don't think we're ever going to get out of that corner. No. We have an additional question from our audience, Peter. Especially in terms of end-to-end monitoring, that audience member would like to know if our agents can monitor jitter as well.
Yeah, they do monitor jitter, yeah. This is a part of the monitoring, so packet loss, jitter, round-trip time. There's one thing, of course, to watch. They have to do this end-to-end, so the agent on the other side should reside on a real platform, not on a virtual-based platform. Why that? It's not depending on us. Virtual platforms don't provide accurate timing. And if you want to monitor so small time intervals like round-trip time or even jitter, then you need something very, very stable, a very stable clock. And if the virtual platform can't provide that, then the measurement wouldn't be good. So that's just one hint and recommendation on that.
Okay, and well, just to round up our Q&A session, of course, the EMA report is available as well. We have this report on our website. I'll just real quickly post the URL to access that report on our website into the chat. And of course, if you have any other questions, we will always be available for more detailed web sessions on any other subject about pricing, about licensing, etc. So that is pretty much a given. Well, thank you very much, Peter, for your presentation. I think we all enjoyed that very much. And also wanted to thank everyone for joining our session today. As I've mentioned in my introduction, we have recorded this session, so the recording will be made available to all of you tomorrow via email. You get a little automated email with a link to download/view the recording. Again, if you have any other questions, feel free to contact either Peter, myself, or any other member of the staff with Infosim. We will keep this session open for a couple of more minutes, just in case anyone from the audience would like to type in another question, so we can attend to that as well. But other than that, Peter, again, thank you very much, and thanks again, everybody, for joining us today, and enjoy the rest of your day. Goodbye.
Yeah, Dietmar, you're welcome, of course. And to the audience, thank you very much for attending. And as Dietmar said, if you have any questions or would like to discuss solutions, we're happy to take any questions or discuss directly, or it's also possible to do to online demonstrations or so. And of course, I did show just a small part of the of the possible solution scenarios these small agents do offer. So feel free to think about more and more applications. I'm pretty sure there are plenty and just share that with us and discuss that with us, and we see how that can work at best for you. So thank you very much again. Good evening, good night to Asia, good morning, good working day to Europe and US, and see you soon on that channel again. Thanks very much. Bye then.
Goodbye.